Okay, hey guys, we're gonna see how this video works, how it turns out, but I'm using my jerry-rigged document camera, and we'll see how well it works to teach you guys about Lewis electron dot structures. So the first thing that we need to talk about when we're talking about Lewis dot structures is we're dealing specifically with covalent bonding. We're not looking at ionic bonding where one electron is ripped completely from one of the atoms and they become ions. We're looking at a situation where two atoms or two or more atoms are sharing electrons between them. They're both fighting over the same electron, but neither one is strong enough to completely pull that electron away. So it comes back to electronegativity. And electronegativity is something that we talked about quite a while ago, or well, we talked about it in class. And so I have a little chart here where we can look at electronegativity values for different atoms. Remember that electronegativity, it's a measure of how difficult, it's a measure of how likely an atom is to hold onto an electron, how strongly it's attracting those electrons from other atoms. And in ionic bonding, the electronegativity of one of the atoms is so great that one of the electrons, or more than one electron, is completely ripped away from the other atom, creating ions. When the electronegativities are less different, for example, if I look at nitrogen and oxygen here, nitrogen has an electronegativity of 3, oxygen has an electronegativity of 3.5. They're not very different. Rule of thumb, if the difference between them is less than 2, it's going to form a covalent bond instead of an ionic bond. Because even though the oxygen is more electronegative than the nitrogen, the oxygen is going to be pulling harder on the electrons that it shares, but it's not strong enough to completely pull them away. Kind of like a game of tug of war, and I think there was a diagram here. Let's see. Yeah, like a game of tug of war. So you have essentially the nuclei that are fighting over the electrons, and so one nucleus is pulling them one way, one nucleus is pulling them the other way, but neither side is pulling completely to the other. Now, if one side was a lot stronger than the other, if one side had a much higher electronegativity than the other side, then those electrons would be completely pulled away. But with a covalent bond, the electronegativities are similar to each other, and so the electrons aren't ripped away, they're just shared between the two of them. Okay, so that's how electronegativity plays into this. When we're dealing with covalent bonds, we can have covalent bonds that have more than one bond between them. So a nitrogen and an oxygen, it can have a single bond where they're sharing 2 electrons. So single bonds share 2 electrons. Like between fluorine and fluorine, a single bond would form, and so we show it with just a single line. We can also have double bonds, and double bonds share 4 electrons. And so an example of a double bonded molecule would be O2, oxygen, has 2 bonds. We show it just like that. That's a double bond. And we also have triple bonds. Where they share 6 electrons. And an example of a triple bonded molecule would be N2, nitrogen bonded to nitrogen, and the 3 lines. Oh man, hopefully we're seeing the pattern by now, but that's a triple bond. That's some notation that we'll need to know. Some other notation that we're going to need to know is that a dot is an electron. Lewis dot diagrams serve the purpose of showing the structure of different molecules, showing where the electrons are in the molecule. Are they being shared between two different atoms? Are they specifically on this atom? And so we use lines to show the bonds. We use a dot to show that it's just an electron. So you got a background of what covalent bonding is in the covalent bonding simulator. Please do the simulator before you watch this video, because you'll need to know what covalent bonding is before we start talking about how to represent it. And we represent covalent bonding using a Lewis dot diagram. And so, hold on. Lewis dot diagrams have some specific steps that make it much easier to draw them than if you just went at it on your own. So if you follow these steps, they will help you draw accurate Lewis dot diagrams. So the first step is to determine the total number of valence electrons. So for all of the atoms in your molecule, you want to count up how many valence electrons each of them has and then add that number together. And you'll be using that number to make sure that you've placed all of the electrons where they need to be. The next step is you're going to put the least electronegative atom in the center. Unless that atom is hydrogen. Hydrogen is our exception here. Hydrogen will always go on the outside. It's never going to be the central atom. Even though it has a fairly high electronegativity of 2.1, or a fairly low electronegativity, let me correct myself there. It always goes on the outside, mainly because hydrogen only has 2 valence electrons. It can only have 2 valence electrons. And so it's never going to be the central atom bonding to multiple other atoms. It's always going to be on the outside. Third step, use pairs of electrons. And a pair is always 2. To form bonds between all the atoms. And so you can do this by putting 2 dots, or you can put the single bond line. Either way. After you've bonded all the atoms together, we need to figure out where the other electrons are going, and so you use the remaining electrons to complete octets around the other atoms, around each atom. Except for hydrogen, because hydrogen, again, its valence shell is full when it has 2 electrons. And so if you are doing step 4 and you run out of electrons to complete octets, then what you do at that point is you introduce multiple bonds. So if you run out of electrons, introduce multiple bonds. And you'll see me have to troubleshoot through those steps, having to kind of go back and be like, oh, well, that didn't work, let's reevaluate that. I'm going to work through several examples in the next video to show you how to draw these Lewis dot diagrams. I'm going to stop this video here just so that it doesn't get too long. The next video will have all the examples.